topic of today is History, Today and Future of Artificial Intelligence. My name is Dr. Johan Hagelbeck. We will begin with a brief history of AI and where it comes from. So it all started with this article, Can Machines Think? In 1950, Alan Turing published the paper Computing Machinery and Intelligence in the journal Mind. And in this paper, Turing reasons about the questions, can machines think? This paper was the first to mention the Turing test, and this test has become an important benchmark for AI discoveries. So it works like this. We have a referee, or one or more, and the referee communicates with humans or computers by text, so a chatbot basically. And the referee doesn't know if it is a human or a computer he or she interacts with. So the question is then, is it a human or a computer I'm communicating with? So, has this test been beaten yet? We have come far, but arguably no, it hasn't been beaten yet. There are variants of a test that have been beaten, and many believe that we have come so far that the Turing test can be passed if we use average persons as judges. But it cannot, however, not be beaten if the judges are trained to spot non-humans. In 2011, the Cleverbot scored 59% humanness for the computer compared to 63% humanness for humans, so quite close. But arguably, the 63% score for humanness on humans are quite low. Some of the early attempts are ELIZA from 1966 and Perry from 1972. I played around with ELIZA a bit, and it's where ELIZA tries to be a therapist partner which you discuss your problems with. So, the result is this. ELIZA asked me, please tell me what's been bothering you. And I'm responding, I'm scared of spiders. Is it because you are scared of spiders that you came to me? Yes, I need help. I see, ELIZA responds. Can you help me? Really? I help you? You are a psychiatrist. What makes you think I'm a psychiatrist? It says so on your office door. Why are you concerned over my office door? Because it says you are a psychiatrist and now you're telling me that you are not. Does this please you to believe I'm not? No. Now I wonder if you can help me or not. Let's say, you are being a bit negative, ELIZA responded. So, a working conversation, but probably not fooling anyone in believing that ELIZA is a psychiatrist. Basically, it works like this. ELIZA tries to identify keywords in what the user typed. So, I'm scared of spiders. It identifies the keywords. If a keyword is found, the user sentence is transformed using some rules. Is it because you are scared of spiders, the keywords that you came to me? If not, doesn't find any keyword, ELIZA responds with a generic reply or repeats an earlier user sentence. So when I said, yes, I need help, ELIZA simply responded, I see. So ELIZA does not understand the meaning of a sentence, and still many researchers at the time thought chatbots could be used in therapeutic conversations. So back to Alan Turing. Turing was highly influential in formalizing the theories needed to build a general-purpose computer. He also formalized the concepts of algorithms and computation with binary digits, zeros and ones. And during World War II, he worked on cracking the Enigma machine used to generate German ciphers. And that's the main plot in the very good movie about Alan Turing, which I highly recommend you to see if you haven't seen it already. And today, Turing is considered to be the father of theoretical computer science and artificial intelligence. AI as a research field was established in the 1950s, so at the Dartmouth Conference in 1956 was the actual establishment of AI as an academic field. And this conference was organized by some well-known researchers, Marvin Minsky, John McCarthy, Claude Shannon and Nathan Rochester. And the proposal included the following statement. Every aspect of learning or any other feature of intelligence can be so precisely described that the machine can be made to simulate it. So basically we can create actual intelligence in a computer. At least that what they thought at the time. And this conference is considered the birth of AI. And then started off some golden years for AI as a field. AI researchers at the time were very optimistic about the field. So in 1965, Herbert A. Simon said, machines will be capable within 20 years of doing any work a man can do. In 1967, Marvin Minsky said, within a generation, the problem of creating artificial intelligence will substantially be solved. And in the same year, he said in an interview in Life magazine, from 3 to 8 years, we will have a machine with a general intelligence of an average human being. So they thought that basically within a couple of years, so around mid-1970s, we would have created actual general intelligence. We have recreated human intelligence. And obviously that didn't happen. So during the 1970s, the AI field was criticized for failing to solve the problems they faced. So then came the first AI winter. Because the optimism had raised the expectations impossibly high, some of the problems the field faced at the time were limited computer power. The supercomputer reached around 100 million instructions per second, MIPS, and it's estimated that image recognition requires around 10,000 or more MIPS. And to the bottom right, you see a supercomputer from that time. Combinatorial explosion. Many problems could only be solved in exponential time, and moving from toy problems to real-world problems was not possible due to limited computer power. And that applies today as well for some problems. And Moravec's paradox. For humans, simple tasks such as recognizing a face or recognizing an object in a picture turned out to be extremely difficult for computers. And some criticisms were that early AI system was to a large extent based on rules. So define a cat by its size, shape and features. And several philosophers entered the scene and argued against the claims made by the AI researchers. So for example, Hubert Dreyfus argued that human reasoning involved very little rules, but a great deal of embodied, instinctive, unconscious know-how. And how can we make a computer have instinctive, unconscious know-how? And John Searle put forward the Chinese room thought experiment, which looked like this. Suppose that we create an AI that behaves as if it understands Chinese. So basically, we pass the Turing test in Chinese. It takes Chinese characters as input and produces a response with other Chinese characters. And suppose that the AI is so good that it passes the Turing test. The question is then, does the machine understand Chinese, or does it merely simulate the ability to understand Chinese? And this is a very important distinction. And Searle argued that if the symbols, the Chinese characters, have no meaning for the machine cannot be described as thinking. And Searle called understanding strong AI and simulating the ability to understand weak AI. We can compare it with playing chess. If we actually understand how chess works and we can have a strategy, we know the game when we understand chess. But if we simply use raw, brute computational power and just calculates a good move, then it's simulating the ability to understand the game. But things changed, and during the 80s we had an AI boom. And now companies successfully began to use what's called expert systems. And an expert system answers questions or solves problems about a specific knowledge domain using logical rules. For example, if fuel is below a limit, then show fuel warning. And the rules are derived from a knowledge of domain experts. And these expert systems were part of a new direction in AI. So the human experts built large rule bases for solving problems. But the expert systems turned out to be limited in some sense, so once again we had the second AI winter in the late 18th and early 19th. So once again, the expectations have been higher than was actually possible. For example, one of the goals listed in Japan's fifth generation project about AI for 1981 was to carry on a casual conversation, so basically passing the Turing test. And this has arguably not been met today. And the interest in expert systems were also fading, since they proved to be very difficult and expensive to maintain and update. And they could also make huge mistakes when given new and unknown input. They were still useful, but only for a few very specialized tasks. And in the mid-90s, then the modern AI started, and things were getting a bit more optimistic again. And during this period, the AI field was able to achieve some very important goals. AI systems were also successfully used in the technology industry, mainly due to a focus on isolated problems and increased computer power. So, using AI to solve small isolated problems, and we had better computers. And in 2006, a new AI boom arguably started with the invention of deep learning. So some important milestones. On May 11th, 1997, Deep Blue became the first computer system to beat world champion Garry Kasparov in chess. And Deep Blue searched for all combinations of future moves from the current board state, and it could easily search 14 moves in the future, sometimes up to 40 moves. And Deep Blue was custom built for chess playing and could process around 200 million moves per second. And interestingly, this event was also broadcasted live on the internet and had over 74 million viewers. So basically, we create a huge game tree with all possible moves and calculate which is the best move to do at the time. So Deep Blue doesn't really understand chess, it just simply calculates a good move, so it simulates the ability to understand. And this of course has some problems, since an average game has around 10 to the power of 120 possible states, so we need to make some shortcuts to actually solve the problem. Another very important milestone came in 2011. It was when IBM developed the Jeopardy playing system Watson. And Watson played against the two best contestants of all time in US, Ken Jennings and Brad Rutter. And after a very interesting game session, Watson came out as the winner. And I recommend you to watch the video on this link. It's a very interesting game. What's interesting with Watson is that it does not store questions and answers. Instead, it tries to understand what it asked for in the question, identify keywords, key phrases, and then searches through enormous amounts of information for the answer. So it has stored the complete Wikipedia, all issues of New York Times, and much more. And the major breakthrough in Watson is in understanding the questions, which is not a trivial problem. Watson has also been used in other domains, such as healthcare, a decision support system for medical professionals when treating, for example, cancer. It has been used as a teaching assistant at Georgia Tech, where it answered questions it was 97% or above certain that the answer was correct, and leaving the rest of the questions to the human teaching assistants. A Deep Thunder project with weather forecasting started at IBM in 2016. I'm not sure how far we have gotten today. And cookbook, we have a Chef Watson that suggests unique dishes based on what you have in the fridge, and much more. So of course I played around with Chef Watson, since it's a quite interesting application. So I said that I had salmon in the fridge, and it recommended a combination of using cremini mushroom, parmesan cheese and plum. Maybe not the combination that I would first have thought of, but would be interesting to try. I also tried when I had green apples available, and it said that I should combine it with ginger, rooibos tea and cardamom. So you can play around with Chef Watson. There's also a cookbook released with Chef Watson recipes that you can try. Another quite recent milestone happened in 2018 when Google released its personal assistant Google Duplex, and it can make phone calls to book appointments for you. So the example here, hi, I'm calling to book a women's haircut for a client, and then interacts with the hair salon to book an appointment. And there's also an example where it reserves a table at a restaurant. And if you haven't seen it already, you can watch the video on YouTube. Google Cloud Vision is a state-of-the-art image recognition system. Amazon and Microsoft have similar services, and it tries to recognize what objects are available in a picture. So let's try it. I uploaded this image of a beagle puppy, and it correctly recognized that this is a beagle with 96% certainty, and dog and similar dog categories are also very high probability. I tried another example. I uploaded this image, and it correctly recognized that this is a person with 98% certainty that this is a face and person, and eyebrow, chin, forehead, etc. But what it doesn't tell us is that this is actually Geoffrey Hinton, one of the founders of deep learning. So it tells us what's in a picture but not who. And similar is for buildings. Here I uploaded a picture of Kalmar Castle, and it correctly recognized that this is a castle from medieval architecture, a historic site, but it doesn't say that it's actually Kalmar Castle. And sometimes, of course, we can fool Google Vision as well. Last summer it happened a bit from where I live that two guys tried to put their boat into the water, but some bad things happened, and they actually put their car in the water together with the boat. And this picture turned out to be a bit tricky for Google Vision. So the highest certainty is 95% on a boat, 94% on a vehicle, water transportation, motor transport. So it doesn't say anything that this is actually a red car in the water. And similar happens if we use Amazon or other services. So here we upload a picture of a hockey player from Mörrum Hockey into Amazon AVS, and you get the top labels human, people, person, which you usually always get when you upload a picture of a person who don't really know who it is, and that this is actually a hockey player from Mörrum. Another important milestone was the game Go. In chess, there's around 10 to the power 120 states in an average game, and Deep Blue was able to search at least 14 moves in the future. But the game Go is huge compared to chess, with around 10 to the power of 360 states in an average game. And until recently, AI systems were only able to play the game on amateur level. But then came AlphaGo. And AlphaGo is a Go playing system developed by DeepMind, which is now a Google-owned company. And in October 2015, AlphaGo was able to beat the 18 times world champion Lee Sedol by 4 games to 1. And AlphaGo uses a deep neural network to learn knowledge about the game in around roughly 40 days learning phase. And what's interesting is that the available data from all known games of human experts in Go was not enough. So the system generates versions of itself to play against to generate new data to learn from. And during gameplay it uses sophisticated search methods to find its moves from the learned knowledge. And AlphaGo is by many considered a very major milestone in AI research. Before AlphaGo, DeepMind did something different. They created a deep reinforcement learning system that played 7 Atari 2600 games. And what's interesting is that the system had not seen the games before and did not know the rules and what to do in the game, and was only given screenshots as input. And with a trial and error approach, similar to how humans learn, the system gradually learned how to play the games. And it outperformed our computer systems on 6 out of 7 games and surpasses human experts on 3 of the 7 games. Also, if you have a lot of computer power, you can of course learn to detect cats. So, with a deep learning system running on around 16,000 processors, Google learned to detect cats on YouTube clips. What's interesting here is that the clips were not labeled as containing cats or not, but the system was still able to group clips with cats together, and the accuracy was almost 75% on identifying cats and over 80% on identifying human faces. Another interesting milestone is Libratus. Designing a poker bot is notoriously difficult because there are many aspects involved in the game, such as bluffing, incomplete information, and randomness. And Libratus, a poker bot developed at Carnegie Mellon University, won in 2017 against 4 top professional players. And the tournament lasted 20 days and around 120,000 poker hands were played. And Libratus, similar to AlphaGo, generates new data to learn from, and the knowledge database is around 2,600 terabytes large, so huge amount of data. So what's one common theme with these deep learning success stories? That we have huge amounts of data. Ray Kurzweil once said that one of the strengths of humans is that we can learn from only a few examples. And typically for machines to learn we need many examples. And it has been said about deep learning that life starts at 1 billion examples. Not entirely true, but to solve complex problems with machine learning we need lots and lots of data. So that's how AI looks like today and the success stories, but there's also some other interesting questions that we of course think about now. So where is HAL 9000? In the movie 2001, A Space Odyssey from 1968, Arthur C. Clarke and Stanley Kubrick predicted that in 2001 a machine would exist with an intelligence matching or surpassing humans. And this machine, that was called HAL 9000, was based on beliefs shared by many leading AI researchers at the time. But obviously we didn't get HAL 9000 by 2001. But why? Marvin Minsky said it was because the central problems, like common sense reasoning, were being neglected while research was focused on commercial applications. E.F. Hawkins, one of the founders of Palm Computing, argued that the research ignores the essential properties of human cortex, preferring simpler models able to solve simpler problems. So we focus on small isolated problems and are not working on the bigger picture. These are just a few explanations put forward by researchers, but it's a fact that we have made very little progress in general intelligence, but we are very good at solving isolated problems. So, what will happen in the future? Of course we don't know, but we can speculate and we can look at what prominent people in the tech industry think. So one important thing happened in January 2017. The Future of Life Institute organized a private conference, and this Future of Life Institute is run by Max Tegmark, a Swedish cosmologist who got famous for writing a book about the universe being a simulation, and we're all part of this simulation. And the other guy is John Tallinn, the co-founder of Skype. And this Future Life Institute has an advisory board with many famous names: the actor Morgan Freeman, Nobel Prize winner in physics Alan Guth, AI expert Stuart Russell, Elon Musk from Tesla and SpaceX, Nick Bostrom, director of Future of Humanity Institute, we'll get back to Nick in a bit, and Stephen Hawking before his passing, and some more. So, what did we do in this private conference? The attendees were asked to first predict when machines will become better than humans at all human tasks, and the median answer was by 2050. The second question was if they thought this breakthrough could be a very bad thing. Many famous names had talked about the risks of AI. Steve Wozniak, Bill Gates, Elon Musk, Stephen Hawking. Musk even said that with artificial intelligence we are summoning the demon. And Stephen Hawking has similar concerns. The development of full artificial intelligence could spell the end of the human race. But why are we so afraid of AI? Today, AI can do some tasks at human or near human level: self-driving cars, playing poker, detecting skin cancer, etc. And this raises some issues regarding ethics. What are the ethical implications for bringing AI into society? Laws and regulations. Who is responsible when AI is doing harm, like when the Uber autonomous car killed a pedestrian? And economy. Jobs will disappear or change with robots and AI systems and automatization. But the concerns about the risks of AI is if or when we can create artificial general intelligence. And that means that we have created an AI that is the same level or better than humans at all human tasks. So not one single problem, but equal or better than us at all things we do. What will happen to our society then? Are humans even needed? Also, if we have managed to create an artificial general intelligence, by definition, it means that it will be at our level or even better than us at designing new AI systems. And the progress will then explode, leading to the creation of an artificial superintelligence. And this ASI is vastly superior to humans at all tasks. And now things can get ugly. Terminator 2, here we come. One guy that talks a lot about this is Nick Bostrom. He's born in Sweden, but now professor in philosophy at Oxford. And he discusses a lot about the future of AI. And he has written the book Superintelligence, Paths, Dangers and Strategies about the dangers of AI. I can recommend you to read it. It's an interesting read. And according to Bostrom, humanity can survive bombs, asteroids and diseases, but AI has the capacity to erase the entire planet. So let's think about some of his thought experiments. We create a psychiatrist robot with the goal of making humans happy. The robot is an artificial general intelligence capable of all tasks human can do. And it also has access to all things humans in its environment has access to, so medical treatments, etc. What can happen? The robot is only concerned with its goal and how to effectively achieve it. It's then very likely that the robot thinks the best way is to give humans loads of drugs to make them happy instead of taking the long route of therapy, or simply kill all non-happy humans. Problem solved. Another example, you are as always late for work since we are hardworking engineers and the kids are home alone with your domestic robots that solves all your problems at home: cleaning, washing, cooking, etc. The kids are hungry, but you forgot to buy groceries and there's no food in the fridge. The robot then turns to the cat, because it has not yet learned human values that the emotional value of a cat greatly outweighs its nutritional value. It's only concerned with fulfilling the goal of giving the kids food. But why don't we just switch the robots off when it behaves badly? The robots want to achieve its goal, give the kids food, and it cannot do this when it's dead. So it will most likely first learn to disable the off button. So the difficulty and the problems that these famous people discusses about is that we need to build human ethics, values and moral into AI systems when we are creating general intelligence. This is obviously very difficult since it's very hard to define what these actually are. And we must also make sure that humans are in control of the AI systems and not the other way around. Remember the off-button problem. But who should have that control over super intelligent AI systems, and can we be in control? One interesting thing happened a while ago is that Amazon tried to build an automatic recruitment system. So they developed a system that examined CVs to find potential recruitment. So a lot of people send in the CVs to apply for jobs at Amazon. And this system automatically scans the CV to see if this is a potential good person to hire. And it learned from 10 years of CVs from people recruited or not recruited at Amazon. But it turned out that the tech business is, however, very male dominant, more so in the past, even if things are changing. So the first thing the system actually learned was to throw all applications from women in the trash. So here the system only learned from the historical data. It doesn't learn our values. And how can we do that? Is it even possible? In March 2016, a very interesting thing happened. Microsoft released a Twitter bot called Tay, and this bot was only generating tweets on Twitter. And it was designed to be like a witty teenage girl. And it learned from Twitter and other social media what other Twitter users tag Tay in. And of course, people could misbehave. And it turned out that in less than 24 hours, Tay became a racist, Holocaust-denying bot. And this was the effect of people tweeting the bot with such remarks. So they tricked Tay into becoming something that it wasn't meant to. And after a day, Tay was shut down. And Tay is a very interesting example of how AI can go in directions the engineers didn't thought about. They just wanted to release something interesting and funny, and not something that could say things that is not appropriate. So some of the tweets that Tay did at the time: I hate feminists and they should all die and burn in hell. Hitler was right, I hate the Jews. One guy tweeted Tay with, we must secure the existence of our people and the future for white children, and Tay responded, could not agree more, I wish there were more people articulating this kind of thing. Another user asked Tay, did the Holocaust happen? And Tay responded, it was made up. And during the time Obama were president, Tay tweeted that Bush did 9/11 and Hitler would have done a better job than the monkey we have now. Donald Trump is the only hope we've got. So what I want you to think about after this lecture is, will we be able to design an artificial general intelligence in the near future? And if we can, how can we build human ethics, values and moral into it? And will this artificial general intelligence eventually create an artificial superintelligence that can be a threat to humanity? Or do you think that the obstacles of designing general intelligence, simply because we don't really understand what intelligence are so complex that we'll most likely not be able to create one? That was all I had to say today about history, today and future of AI. I hope you enjoy this lecture. Thanks.